Hello audience, my name is Victor. This person right here is my partner Lewis. And we built a project for design modeling class. This is called the FarmBot. This is a robot that can automatically drop seeds onto tilled dirt or farmland. This is very important because it can solve a really important world issue. And that world issue being farming. You see, farmers, when they have to farm agriculture, they have to carry a big bucket around with seeds, and then they have to either drop it or they have to bend down and place it, which is very painful and it's very inefficient. Anyways, to fix this, we built a project called FarmBot. Like I said already, it plants seeds onto farmland. Added on, this robot is powered using microbits, a type of coding made by Microsoft. The way it moves is that it has two very powerful remote control robots, and that works as the legs. Besides the point, it functions by having two ramps that seeds fall onto that guide it into a certain direction. Then there's a spinning door that makes it so that the seeds drop in a good format. We have been working on this for almost 10 weeks, constructing it, as well as coding it. It has taken a long time. Hello audience, this is how you turn on the FarmBot so it can do its function. Starting first, you go to the microbit right here, and you press A to start. First, to make it stop, you press B. You wait till it starts completely spinning. There's a certain sound you can hear. Then, you will start moving soon. Then we place the seed box, which has a tiny hole here. And then you just simply flip it over, and then the driver will start moving. And as you can see, it is the floor, so it's going everywhere. But on farmland, it is rock, so it won't bounce everywhere. You can stop whatever. And as you can see, folks, this is the FarmBot working. This was built by Victor and Lewis. We're signing off. The world issue that we decided to tackle is farming. Anyway, okay, the problem. You see, the problem with farming is that it's limited by the actual farmer. What if it was different? Well, with lots of work, me and Luis successfully built a robot that can drop seeds evenly onto farmland. This mechanism can be replicated onto an entire farm. This issue is very important because farming happens in every single continent. I mean, except for Antarctica, but additionally,
Let me pause you. We're gonna start the whole presentation. Anybody who interrupts their speech, their presentation by talking, you're losing 10 points. Right? Start over again. No, you can give any feedback or comment at the end of the presentation. Start again from the problem. From this side.
the problem. You see, the problem with farming is that it's limited by the actual farmer. What if that was different? Well, with lots of work, Lisa and I successfully built a robot that can drop seeds onto farmland, and this can be replicated throughout the entire farm if the robot is running. This issue is very important because farming happens in every single continent. Additionally, farming helps supplies humans with necessary items for survival. Farming does not it can include more than just food. It can include materials, like oil. The potential clients for this project is farmers and planters. So this mainly focuses on farmers that are finding out for food and items to eat. This will be able to run. They will be able to run the robot, and it'll work for them. The device is unique because it hasn't been replicated, especially to this extent. Even the adults that went into the classroom a few weeks ago, that interviewed us, you might not know, said that they haven't seen anything similar to our project. Here are the design requirements. It needs to be either a programmable or has to use a remote control so the farmer can sit back and relax and use a remote control, or it is programmed for them. It needs to have an on and off switch. That means that when they're finished with their farming job, they can turn it off and they can relax. It needs to use microbits. Microbit is a type of coding that uses blocks for JavaScript. Blocks is focused similar. Is very similar to JavaScript. If I'm not mistaken, it's made by Microsoft. It needs to look good quality and aesthetically pleasing. Not only does it have to look good quality, but it has to be good quality. Good quality. It needs to be able to plant seeds evenly on the ground. It can't be all over the place. It can't go into the farmer's face. It needs to have the necessary features to make farming a more enjoyable experience. Because, as you know, farming it's pretty difficult. It needs to be able. It needs to be able to be tweakable. If the farmer wants to code some more, they will do so. Next slide, please. Okay, the generated concepts. We had a few ideas, some of which would have incorporated items that we sadly did not have. One of the best ideas was using a sliding door. One of our favorite ideas was incorporating was a sliding door, but we sadly couldn't make it because it used a breadboard, which is something that functions with a microbit, but we did not have that. Anyways, the way this would work is that basically the seeds would fall using gravity, and the sliding door would open and close, so seeds can fall onto farmland, but by using the sliding door. It was actually a very good design, but sadly we didn't have the materials to make it. It was also very hard to make. We would need it the way some old-fashioned trains work is that some of their wheels are connected and it works like this, and that was somewhat of what a sliding door would work. It would have been very difficult. Do you have anything to say, Luis? Okay. Generating concepts number 2. Another concept we had was using centrifugal force. Centrifugal force is when something is spinning very quickly. That if something is placed in the middle, it could fly out. If I'm holding onto somebody and I start spinning very fast, they will get pulled back. That was what centrifugal force is. So another concept was using centrifugal force, and it would be used to disperse the seeds. Basically, we would have a wagon, and then we'd place the seeds. It would spin, and they would fly out. Although it would have dropped all the seeds at once, which was been very good because you need to use this for a long time. Also, it was very messy. With one rotation, it could stop it working. Adding on, the servo motors were too slow to conduct centrifugal force at the level that we needed. The way the machine worked is that you put seeds directly in the center of the roulette wheel-styled wheel. It's a roulette wheel-styled wheel, so it would spin one direction, and then you could stop and spin the other direction. Then you would spin the disc, and the seeds would fly in all directions. Although we added walls to the back. Somebody say something?
Carry on.
We had set walls in the back so the seeds didn't fly out this way. But as you can imagine, that still didn't work because of we had to make turns, and it sadly did not work out. It was very scuffed, and frankly, it looked very ugly. And if you're carrying it and you just dropped it, all the seeds could on the floor, go in one spot. Okay, generate concepts number 3. After all the struggles, Lewis and I produced a design that was super good. We produced it, what I like to call the 3-layer cake. Basically, we had a trailer, a wagon that would have these 3 layers. The top layer would be the layer where you hold the seeds. The second layer was the largest layer that would have a ramp that would drop the seeds to the necessary spot. The bottom layer was all the techniques and all the robotics would be located. It would be how the brain machine would be located in the bottom layer. It's also where the door is located. Speaking of which, the door is a flat plane that continuously spins, which you can imagine the seeds fall and they can stop, and then fall, stop. And this is a very good design because unlike a sliding door, it doesn't have to use any. It can just use a basic rotation. Sadly, one very important factor that did not work with that mechanism is what pulls the trailer. We originally had this robotic programmable toy, but we switched to remote control robots underneath, which are located right here and right here. Uh, in our remote control power, it seems to be turning a lot better. And the turning would be a lot better. Because turning using a wagon, it could tip over. The picture at the top right is a picture of the first successful design. Like I said, the one programmable robot. We're still kind of stuck there. But over time, we had a lot of different. We added lots of differences and lots of new features. Some very important info I'd like to inform you guys is that Lewis and I both agreed on a design that is quite similar to each other. We agreed together, we brainstormed together. So we didn't blaze off in something different. So here's the more in-depth of the sketches, a larger picture of the sketches and schematics. Like I said, right at the top, right here is the wagon and the robot. But then we switched off to more of a singular design. It's not a wagon anymore, and it would have the robots, and it would somehow drop the seeds. So we originally thought we could use treads, but because that would be very sturdy to the ground, so we decided to use the robots. Actually, had mini treads. We also thought that we could use like a pipe of a vacuum to drop the seeds. That's why, as you can see in the farm bot and the O, it has some duct tape over it because we originally wanted to use a vacuum pipe to drop the seeds, but that doesn't work anymore. So this is just a basic sketch of what it looks like. It is going to be a box with a flat plane to disperse the so that it doesn't tip over. It basically functions as a tightrope, so it doesn't tip. You know how people they go on it and the center of gravity is good enough so they don't tip over. Next slide, please. So we use the decision matrix to think of different ideas, and we can also merge some ideas in case some ideas were good and some ideas were bad. As you can see, the picture on the right is a picture of the chart that Lewis and I used and discussed to solve the world issue. So the first idea was the centrifugal force. It uses motors, it dropped the seeds, but very unpredictably. It uses centrifugal force to launch the seeds to the farmland. That's how it solved it. It does meet the design criteria. We will not be able to actually build this because the servo motors do not spin that quickly, like I said. And can it be completed in a reasonable time? Yes, it can. But we need materials that we do not have. The idea two is the sliding door. Use the sliding door. That's the inputs used, outputs used. Yeah, it drops seeds. It solves the world issue by dropping the seeds using a sliding door. We sadly can't build this because it requires a breadboard and the other thing with the sliding door is that the servo motors also couldn't work too slow for this. And can it be completed in a reasonable time? Theoretically, it can. 3-layer cake. Inputs used is it uses a spinning door. Outputs used it drops the seeds, and it's a lot faster and it's predictable. It uses ramps and spinning doors to drop the seats, like I said already. It does meet the design criteria. Will we be able to get the materials? Yes, we can. You can see, you can imagine, we got them. And can we complete it in a reasonable time? Yes, it can. We had a prediction of 16 weeks. We think we got it a little bit faster. Okay, the Tinkercad models. Like I said, the first model right here, this white thing was the programmable robot. It kind of looks like Wally in a way, and it would pull the second the wagon. But the third one was its own. You want to say something? No. The second thing would be its own wagon. It would pull itself. Here is the side by side, and as you can see, they both drop seeds. Although this is not a wagon, which does function a lot better. Version 1 versus version 2, they are definitely very similar. Although version 2, it seems to be a lot sturdier and
it can take on hits more often. If there is rain, we made somewhat of a shape that can deflect the rain in a way. We added a spoiler, so a spoiler that we use to lift the machine if we the mechanism the door. So and it's tilted in a way so that raindrops fall and just like that. Uh, coding. So we spent 4 to 6 weeks coding. We built very stuff, but it did work. A coding script that we could use for a robot. It was over 30 lines long, 30 blocks long. Then we compacted it into something very small. It's you want us to say? No. All right. Sorry. So as you can see here, this is not part of the coding. It's just a box. So this is the bare bones code. It took a very long time to make it compact and make it smaller. Here is the secondary code. We added Easter eggs and tiny little features to make the farming experience better. For example, after 1 hour of use, it's gonna say hashtag I'm tired. And if for any chance the robot free falls, it's gonna say help me. It's just a tiny little reference. And since blocks is very similar to coding, we could translate it. And here's what it looks in JavaScript. All right. Materials that are necessary. For this project, we will need construction paper, cardboard, duct tape, clear tape, pins, rubber bands, seeds, scotch tape, thin plastic styrofoam, thin cardboard, microbit servo motor, alligator clips, battery for the microbit, specifically AAA, really rad robots, which are the remote control cars that we're using, generic Lego bricks, so just basic 2x4 blocks, Lego monster truck wheels, and Lego monster truck tires. And lastly, lots and a very large quantity of hot glue. The items that we need to construct this are the scissors, because we're not attaching scissors, we're just using them. Scissors, pins, pencils, markers, rulers, hot glue guns, and box cutters. Here are some pictures. And this thing is the really rad robot, and this is the exact one that we use. We have two. We have a blue one and a red one, and we actually have a blue one with the same exact remote. All right, building the prototype. A very large part of this project was coding. Lewis and I spent 4 weeks learning and coding that would be suitable for this project. We used blocks, a type of coding that revolves around JavaScript. After a very long time, Lewis and I got a successful code. We later used it for a project, and it still works to this day. Some very important information, like I said previously, is that it was originally a mess of over 30 blocks. But over time, we made it more compact and tweaked it. Something that was also a mess was the alligator clips. Originally, it was a mess. If any of you guys know how computer parts works and like CPUs, sometimes they can be a total mess. But we organized it, and it looks like it was made by a machine in a way. And we tied them up. Right here is the picture of the different components that we use. So we built the top part here that holds the C's. And by the way, remember I said that we could tweak it? Right here is the USB that you use to tweak it. And it is nice and snug. It might look like it fall out, but it is definitely very snug. Here's the remote. We added some tape to see directions. And here are the seeds. This is what we use. I think it's basmati rice, chia seeds, and we used a small cup with a hole at the bottom. And we could also use sticky notes to open and close it. It was just a temporary testing and polishing. When Lewis and I needed to test our project, we used tables and floors that in the classroom. Although the carpet has lots of friction, it is very sticky and strong. So we occasionally tested our project outside to see if everything worked correctly. Adding on, every day we test our code to see if it still works. Some days I thought the code broke for some reason. A is start and B is stop. Okay, one day the B just completely didn't work. We didn't know what exactly happened, but we eventually fixed it. Here's the pictures. Here is the inside. You might not know what the inside looks like, but there it really is. This is the ramp. Remember we talked about ramps? Here are the ramps. Next up, please. Okay, our vision is that the farm bot will be used in every farm in the world. I don't want to seem like we're on Shark Tank, but hopefully it will be used in real life. You can make modifications, like I previously said, so the farmer can make any differences. Reflection. Overall, the project was a success. It fixed the world issue that we're trying to solve. It was a very difficult journey. Over 10 weeks of struggle and determination. We were trying to be very resilient. There was lots of roadblocks along the journey. And overall, I think we finished. You can, I need to thank you for attending this presentation. With warm regards, Victor and Louise. Thank you.